Garrett, you feeling sick? I didn't know if you were feeling sick or if you just like to be safe with your mask.
No, I think it's coming down now.
Well, I appreciate you wearing a mask when you feel bad. I wish everybody would do that. We'd all be a little less sick if that happened. Oh, I'm sorry, this is. There we go. My A-Day classes are like 2 days ahead of y'all, right? Yeah. Hard to keep up.
Is there anything important happening Friday? Because I'm not too sure.
We will be doing the 4.3 quiz and working on the test review. You picked up the test review when you came in, no?
Trigger identities worksheet. You said we had to do a few on the back. Did we have to submit it with it like entirely completed?
No.
Okay.
I've opened that up in Google Classroom for my 8A classes, and I just do them at the same time as y'all.
Okay.
But we're going to spend most of your class time today. We'll be working on finishing.
I submitted it yesterday, that's why.
Yeah, you'll just need to resubmit it when it's finished.
Okay.
I didn't ask you to finish it yet, but I will today.
I don't even know what's happening.
Is the quiz for this unit on Friday? Or is it next week?
This unit is next class, so Thursday.
Okay.
Sign when you need a book. Okay, I need y'all to get out your number 13 book assignment, and you will also need your number 16 trig worksheet. How's the day? It's all right. 3, just a lot. just a lot of stuff going on. Okay, so you have to bear with me here a little bit because my A-Day class is a few days ahead of y'all, so my brain kind of has to jump back in time here. But what was your homework last time I saw you? Is I said it would be a good idea if you did a couple of the questions on the back of handout 16, just so you had a little bit less to do. But the important thing was to finish up the book assignment, which was number 13. And I know that the website has videos of all of those things, but sometimes the videos don't quite cover what you need. So I like to always give you one other chance if the video was not enough to get clarification there. So let's go ahead and talk about the plan for class. So because some of you may not have questions or probably don't have questions and you know what to move on to. So I'm going to wrap up any other book questions you guys have. I will remind you that we have our 4.3 quiz next class, but I'm going to go ahead and say this now and I'll try to remind you of this later. Usually what students worry about for the 4.3 quiz is the trig identities, and there is 2 trig identities on that quiz, and they're 3 points each, so that totals 6 points. But the 4.3 quiz is 30 points total, so only 6 of them are trig proofs, and my 8A class has already had to take it, and honestly that's probably the part they did the best on. The other part of it is the stuff from the book assignment. So like looking at the book assignment right now, questions 5, 7, and 11 are the same type of question, so there's probably one of those on the quiz. 15, 17, 39, and 40 are kind of the same type of question, so there's probably one of those on the quiz. 23 through 28 are the same type, so there's probably one of those on the quiz. 23, 25, and 57 are the same type of questions, so there's probably one of those on the quiz. And if you don't look back at that stuff and you just hope that you remember that from sometime last week, that's when it doesn't go as well. But the majority of the points, 24 out of the 30 points, come from unit circle, straight from the book type questions. Okay, so I'm going to take your questions out of the book, but if you don't have questions or as someone's asking a question you don't need help with, you can try one of those questions on the back for number 16. That's probably where the bulk of your class time is going to be today. With our 4.3 quiz next class, I've asked for some of the assignments to be turned in. Some of those have been open for a while, like the 4.3 notes I think have been open for a while, but I just recently attached a due date to those. So you'll need to have those in before we start next class. It's the notes, the basic proofs, the longer proofs when you finish it, and the book assignment. Obviously all that's in Google Classroom, so you don't have to catch that now. And then finally, I do like to give you the test review early. Obviously our test is not next class, but the 2 pieces of paper you guys picked up on your way in, those make up number 18 in your binder. And the reason why I give these to you early is if you look at questions 1, 2, 3, and 4 on the front, and question 19 on the back, those are questions from 4.3. So if you do those between now and Thursday, that should help you with your 4.3 quiz, because some of those questions are probably on the 4.3 quiz. And then also you would have part of your test review done. So that's why I give it to you early and suggest that you at least do those questions. Trying to point all that out to you guys just based on how quickly you move along today. Okay, so if you had any book questions to finish up that work, please tell me what you've got, and if you don't, go ahead and try some of those on the worksheet from last class. Yeah. 39. Okay, so check and see if 39s you need help with. If you do, then great, follow along. If you don't, then work on one of those other couple things that you'll need to do later anyway. Now this looks a lot like, I think, question 1 on the test review. It's got a couple different parts. And I would say students that don't review their book assignment, when they get to the quiz, what happens is they say, all right, well, cosine's 1/3, so secant would be 3. And then some students are going to keep on going and some are going to hit a wall here. The start of this, just like question 40, just like question 15, just like question 17, this is why it's always beneficial to review, even if you did them, is just because they didn't make a triangle for you doesn't mean that you can't make a triangle. If they gave you cosine, then you can label adjacent and hypotenuse. And if you have 2 of 3 sides of a right triangle, you could do Pythagorean theorem. Make sure you know how to reduce the square root of 8. I can go back over that if I need to. But then once you know this side, SOHCAHTOA tells you how to pair everything else up. Sine is opposite over hypotenuse. Now that I have opposite, that's not a problem. Tangent is opposite over adjacent. I've got that information now. And then this one's usually kind of funny looking too. And this honestly can be the easiest question on here, but only if you really memorize those basic trig identities we asked you to. This is one of the cofunctions. And the cosecant of 90 minus theta is the same thing as what? So the answer was right there. If you don't know the cofunctions though, then there's not much, you can't just be creative and just kind of figure that one out. Okay, is there something more specific about 39? Jonathan, this is your question. By far I'd say for 99% of the people, if you have issues on it, it's that you didn't consider making a picture. So add that to your notes, add that to your book assignment, make it a note that you will read if you look over it during advisory before class on Thursday. Because it's not any harder than the others after that. Okay, somebody else have another one? Or did somebody else have something more detailed about 39 before I take it away?
Was there an A part to that, or a B part, or just an A part, or just that part? Because I remember correctly, there was something on the other side too, but I could be wrong.
39 had 4 questions.
Okay, all right.
That was all 4 of them. Okay, what other questions do you have? Okay, that is fine, but just double checking. Nothing else from the bookwork y'all want clarification on? Okay, then it looks like the majority of us should be looking at this trig proofs worksheet. So as we started this last class, and I know it's been a little while now, in my opinion, I think this is one of the harder things we do because you don't always know the path to take. You have to have the basic trig identities memorized. Some questions can be frustrating because you can do several steps not incorrectly, but they may just not help. But honestly, they should get a little bit easier because the tips and tools that we use on each question should carry on quite a bit. You do still need to do question 8. Some people in my 8A classes got half credit because I said you didn't have to do question 8, and that's true on day 1. That was last class for y'all. But now today I'm giving you time. I would still save it for the end because I think it's the hardest one, but you still have to have it completed. But I did suggest that you try a few on the back. So there's no point in waiting for questions there if you know that there's one or more of those that you could have tried. But let me give some direction here before I just let you pick a question or two to work out. I would like to talk about 10 and 11. Because I think there's something of value here that I can help guide you and make. This a little bit easier. So what do y'all think the first step to this should be? What was probably the most common thing we did last time that worked?
Switch sine with sine and cosine.
Okay, you could change everything to sine and cosine, but I really think that you should save that for the... Do what? Okay, maybe split apart your fraction. So I would say the most common thing that people try on this one is splitting apart the fraction. Now this part is pretty easy to see. This is going to go to sine if you just know your reciprocal identities. This mess, you're going to have to change everything to sines and cosines and divide your fractions. And I'm not saying that that doesn't work or won't work, but
Sorry.
that's fine.
It's a water bottle for us.
I never heard water bottle make so much noise. But I think there's a lot quicker way to do this one. So this goes back to a lot of these questions can be worked multiple ways, but of course you want to try to pick out the one that looks easiest. So one thing I really pushed on you guys last class was writing out the 3 Pythagorean identities carefully once at the top of your page. Sine squared plus cosine squared equals 1. That's the most common one. I really hope you have that memorized without writing it down. And then we said you could divide everything by sine squared to get another one. And you could divide everything by cosine squared to get the third one. Or you can just memorize all 3. The reason I'm pointing this out is notice if you have those to glance at the top of your page, you have an alternate root on this question. This 1 plus cotangent squared is the same thing as what? Cosecant squared. And what do you think cosecant squared divided by cosecant is going to be? And what's another way to say cosecant? And if you do it that way, there's nothing wrong with the other way, but I really feel like that's a lot more efficient. So again, this is where it goes back to where these can be kind of frustrating. Splitting apart our fraction is a great strategy 95% of the time, but on this question I think that's probably the harder path. If you recognize the top as a Pythagorean identity, or you at least have these up here where you can glance at them and then see that it's a Pythagorean identity, that one can be quite a bit more efficient. Okay, and then I want to talk about one more, because I think it's also a little bit easier to catch up on. Well, I'm sorry, I want to do 2 more, because I know one question you guys will have. Okay, what do you guys think might be a good start for number 11? Did anyone try this one yet?
Plug in 1 for sine plus cosine.
Well, not sine plus cosine, but sine squared plus cosine squared is 1. Those squares are important, so I just have to make sure. Everybody agree sine squared plus cosine squared is 1, first Pythagorean identity? I know it's not as easy to see because they're not directly next to each other, but that is that. And then how am I supposed to show 1 plus cotangent squared is cosecant squared? It's just one of our Pythagorean identities. Again, if you have that written at the top of your page, you are welcome to make that substitution without proving it. If you don't know those 3 Pythagorean identities, you're going to have to change this to sines and cosines. You're going to have to get a common denominator, and you're going to have to add your fractions. So you can still do it, but you're going to make it a lot harder on yourself. So 11 can really just be 2 Pythagorean identities. 1 plus cotangent squared. 1 plus cotangent squared is cosecant squared. And again, one more reason why I think you should have this at the top of your page. Much easier to just glance at. Okay, before I give you a few minutes to try some and see where you're getting stuck and which questions you're getting stuck on, a question that came up in a lot of my other classes, my 8A class a few classes ago, was about how to start question 13. And that's completely legitimate because this did not show up in any other question, but it's an algebra scope that I know you need at least one more question besides this one. When I look at this, what I see is the difference of 2 squares. And the difference of 2 squares always factors like this. So I could say I've got cosine squared being squared on the left, sine squared being squared on the right. One needs to be a plus and one needs to be a minus. And factoring the difference of 2 squares is not always obvious, but if you look at the numerator in 16, that looks like the difference of 2 squares too. Part of how I know to maybe try that is none of our identities, the things that we memorize, are to the 4th power. So I've got to have some other way to rewrite those. So I still want you to try it, but I did push you in the right direction on the first step. Factor the difference of 2 squares, and then consider factoring the difference of 2 squares on the start of 16 also. Okay, so those are the ones I wanted to talk about. Are there any that you have fully tried and you want me to help you get past the step you got stuck on? Okay, what did you try?
I flipped everything first, so I converted. I converted secant and tan, and I flipped those. And
Okay, when you say converted, I'm assuming you mean...
I put cosine on top instead of secant, and then I put cotangent on top instead of...
Okay, you can't just move up terms like that. You can move factors and not terms. You can write secant as 1 over cosine. You could write tangent as sine over cosine. But you can't just move this to the numerator and make it cosine and move this to the numerator and make it cotangent. You're just completely ignoring that plus sign when you do that. So I'm okay with this step. Alright, what can we do with these denominators now?
You can add them.
Okay, we can add them, and even better than that, they already have a common denominator.
You can divide it, right?
Right, and a lot of times, this is called vertical format. Sometimes it's hard for y'all to see how to deal with this written in vertical format. So let me recommend to you try horizontal format. I've got a cosine divided by this stuff. And a lot of times I think if you write it that way, it's a little bit easier for you to think of dividing fractions as the same as multiplying by the reciprocals. Okay, and if I'm peeking over at the right side, do you see how the right side doesn't have anything to do with cosines? But I have cosines? Well, that's my hint. I need to change this somehow. So what is cosine squared equal to? What kind of replacement can we make for that?
You multiply each side by 1 plus sine.
You can't multiply both sides by anything. You're not solving an equation. One side needs to stay alone. What is cosine squared equal to in terms of sine squareds? Not 1 over sine squared, that is cosecant squared. 1 minus sine squared. First Pythagorean identity, cosine squared is equal to 1 minus sine squared. Okay, and then this is something, a tip I gave y'all just a few minutes ago. How can we make this numerator look different?
You could put cosecant. No. Tangent up there?
Instead of this, 1 minus sine squared is tangent squared?
No, cosine squared.
Okay, well then you're going backwards to this step. So that's not wrong, but what's the algebra trick I told you to think about? You guys would better start studying this a lot, because I just less than 5 minutes ago said difference of two squares. If you don't see the difference of two squares after that much of a hint, then you've got to study and practice more. Factor that as the difference of two squares, and then it cancels out and gives you what you want. I can't help you see what you need to see, though. It does get easier with practice, but you got to consider some of the stuff that works on one question, you got to consider it on the other question. So, difference of two squares. Okay, so go ahead and try one of the others. Doesn't matter which one. In fact, I would probably pick one that whatever looks the easiest to you from what's left over, and then work your way out to what's the hardest. And some of these are pretty tough, but you've got a big chunk of time in class right now to work on it, and I'll come around to give you hints. I'm not going to help you finish the question, but I'll try to help you get unstuck. If I see the same mistake in a lot of places, I'll talk about it on the board so everyone can get benefit from it. But as you finish that, you can turn all that stuff into Google Classroom so that you don't have to do that for homework. And then if you have class time, I would suggest you do 1 through 4 and 19 on the test review you picked up from your way. We'll also suggest, again, I know our quiz only has two trait proofs, and people did pretty well on them. But questions that you're struggling with or missed, you should probably circle them. And if you really learned from them what you need to, you redo them tomorrow or Thursday before class. You should be able to redo those and see that it actually stuck with you. Yeah, nothing else really jumped out at me on that one. Okay, I'll do that as well. Really, this guy has a 2, this guy has a 2, this guy has a 3. I multiply this denominator by common denominator can be sine times cosine. You gotta multiply the top and the bottom of your left fraction based on what this denominator needed and
When is our test?
we have quiz next class. That's Thursday, then we'll do test review on Friday, and then the test will be class after. So a week from now. Anything I can get the next one?
Next class, maybe what's that?
It is difference of squares, but I don't think that's gonna help you because that would give you, when I look at this, you see how you have cosine squares and sine squares, but the other side's only cosine squares? So kind of like near the end of this question. You see how we had cosine squares, and I changed them to sine squares? So use the cosine squared is the same as 1 minus sine squared. So if you change that to 1 minus sine squared, then you're going to end up with 2, change the sine squared, not cosine squared. Change that, and then you're going to end up with 2 of those. You should have a minus 1. I'm done with both questions. I just gave you a chance. That was homework. Never down. No, I'm helping people with other stuff. That should have already been ready to ask. But if you had done that for homework, you would have known what questions you needed to ask.
I thought I needed 39 and 40. I can solve 40 now. I looked over here, I realized that
What is it?
it's 38.
Okay, well, what is different about it than,
Well, here, you're supposed to plot it out, or do the same thing. All you have to do is you have to chart, and you try to figure it out from there. But 30, I don't know if I'm supposed to, because here I made a drawing. But here, I'm thinking I can make a drawing.
you could,
I still,
but those are also unit circle spots, so,
it's 30 would be like here.
correct.
So I don't know what I'm talking about.
That's saying at 30 degrees, the tangent is square root of 3 over 3. That's what we did in section 4.2. That's a unit circle question. How do you find tangent values? So it's the sine at 30 degrees.
It's square root of 3 over 2.
That's cosine.
So sine would be y, so 1/2.
So take 1/2
1/2.
divided by cosine, square root of 3 over 2. And when you divide those, you would get that. But you don't have to do that one. They're telling you what that one is. They're giving you a hint. You should be able to find that too from the circle.
Now I see what's sine.
Now cosecant at 30 is going to be the reciprocal of
Cosecant is cosine. Cosine x would be 2 over square root.
cosecant's the reciprocal of sine though.
Cosecant is sine. That should be positive. This would be 2.
Yep. Also, I did this one for you in class too.
I remember. And I followed with 38.
Is this not 38?
But this is, we don't even pay this and this. Now it's this one.
I don't know the difference.
On 38, you have one here, and then
You know, those are both the same thing.
same.
Look, sine is a half. They just told you sine is a half.
So then why would they give me sine?
They're just giving you clues. They didn't have to tell you either one of those. All of those, you should be able to tell me the cosecant of 30, cotangent of 60, cosine of 30, and cotangent of 30 just from the unit circle. These clues are trying to give you a hint to make it a little bit faster, but you don't even need those.
Okay, alright.
That's why I did that one with you. You need to maybe add some notes to your work so that you remember. You gotta get a common denominator. And then multiply the top and the bottom of each fraction by what's missing. So this common denominator is going to be a 1 plus sign and a 1 minus sign. If you multiply this one by 1 minus sign, you got to multiply the top by 1 minus sign to keep it balanced. If you multiply this by 1 plus sign, you got to multiply that by 1 plus sign. And then once they have a common denominator, you can push them all together.
I'm gonna be here on Tuesday for the test. When I
Okay.
come in, do I write it up and then I see?
Yeah, I'll sign you up prime time, or you should probably try to sign up for prime time.
Okay.
On Wednesday.
I have ambassadors third period too, so maybe I could like take the test then on Monday or something.
I have a different class Thursday,
Okay.
or third period, I can't do that.
Yeah.
It looks like you have class ring stuff on Wednesday, so I didn't change that, but Thursday, you're in advisory.
Okay, is that enough, one advisory period to take the test, or should I do?
What I'll do is I'll give you 1 page of it, and then if you finish and you think you have time for the second page, I'll let you do the second page, and if
Okay.
you don't, then we'll just have to.
Okay,
take it.
thanks.
Did that get you? You can do it. Go ahead and write it down. Okay, go.
I just didn't register it as wrong, I guess. Have you done 14 and 15? Do something. Or should it just be one and then it would be secant times secant.
Okay.
So right here, would I be done right here, or do I need to do something else? Because
Well, it was 5 minus 3, the same thing as negative 5 times 3.
I guess I was thinking. I mean, okay. I guess not. They kind of look like the same thing, just kind of.
Yeah, they're very close. But that's what makes this one kind of hard, because usually you have to do a little bit of work to get here, and then it looks like you're almost there, but you still got a few more steps to go. If you change this into sines and cosines, this would be cosine squared over sine squared. Then you can look at these as two fractions, like this one was.
Would you
if-
convert this one into sines and cosines too, or no? Just the one on the right?
Well, this is already in terms of cosine.
Oh, duh. Okay.
Yeah, but then if you add those fractions together, it pushes them into one big term.
Okay.
So that's what you
gotcha.
gotta try to do.
Thank you.
Okay, it's been a few minutes here, so I know you all are kind of on different ones, but has anyone tried question 12 and gotten stuck on question 12? If you just haven't tried it yet because you're jumping around, that's fine too. But if someone needed help with it, we could look at that one. Yeah, number 12? Okay. So, no, I don't see any algebra that jumps out at me at this question, but you should have at least changed things in the sines and cosines. So I'm assuming you did that at least. And then cotangent. Okay, did you do that step? Okay, then that's what you have to write down, because I can't, like I can say all of these different things 50 times to you guys, but if it doesn't stick after the second time, you've got to start writing down. Changing everything in the sines and cosines is sometimes the only way to move forward.
I wrote this down earlier, but I didn't know what to do with this, so I saw.
Okay, that's fine. I understand. But I need you to see that first step, if nothing else. Hello? He is not. Oh, wait, hold on, say it one more time. No, he's not. I don't think he was here last time either. Yep. Yep, sorry. Bye. What I would do is get these two to combine together. So you can force these two together by adding your fractions. So to add fractions, you need a common denominator. This is what the left fraction currently says. This is what the right fraction currently says. This one's missing a cosine, but if you multiply the denominator by cosine, you better multiply the numerator by cosine. That way it's like you're multiplying by 1. This one's missing the sine. And same idea. If you multiply its denominator, you have to multiply its numerator. And so over here, you get sine squared plus cosine squared. And the fact that that sounds familiar means it's probably on the right track. And when you get a common denominator, you can push them together with that common denominator. Okay, and what is sine squared plus cosine squared? Okay, so instead of this vertical format, which is sometimes hard for y'all to see how to move forward, write it horizontal. We've got 1 divided by, 1 divided by. This becomes 1. And then the way you divide fractions is to keep, change, flip. And I don't know. Cosine times sine is the same as sine times cosine, so I'm just going to switch those. Now, I know I said this last class, but my other classes also had issues with this. Make sure that you guys don't quit like right here. I don't know what it is about these questions, but a lot of times you guys get right at the end and then you realize that you did it correctly. So like you maybe don't write it down. If you do this on the quiz, I can't give you full points. It looks like you got stuck here and you didn't know what to do. Your last step on every single question needs to be the exact same thing on the left and the right. Okay, so are you okay with how I added these fractions together?
Yeah, I didn't want you to finish it though. I was trying to keep it right here. So I
Okay,
missed that.
I'll leave it up then, so you can compare it to it. Okay, we can look at some more later, but hopefully that helps you some. There's several on Saturday that add fractions. I'm pretty sure 14, you need to get a common denominator and add fractions as well.
What is it?
Okay. To subtract fractions, you need a common denominator. So multiply the left fraction by sine squared over sine squared.
Is that everything after we do that one? Yeah, I just think
Okay, so I just kind of looking for something to where you can subtract them. So
Subtract fractions, you have to have a common denominator.
but you said denominator.
So you want to change this denominator to sign. So multiply by sign. Write it down. But you can't just multiply the denominator by sign. You still didn't write it. I still don't see it.
Are you talking about both? Or?
You gotta do both, top and the bottom. So it's like you're multiplying by 1. Because anything divided by itself is 1. Now that they both have the same denominator, you can push these together. So you can take this minus this, it's all over sign.
How would I write that? Like, how would I combine them and write that? Is it
How would you? How would you do 3/4 minus 1/4?
just subtracted 3 minus 1?
Okay, you subtract the numerators and you put them over the common denominator. Well, one of those is the form of that. So if you make that change,
I thought it, okay, first I thought it would be this one, but I thought it would have to be 1 minus sine squared. No, it would be this one.
there's sine squared, they subtract 1 over, sine squared minus 1, and then you have to subtract this over.
Well, if you did, because I thought of it like minus sine squared and minus sine squared. So,
Yeah.
what?
So then 1 minus sine squared is equal to cosine squared. So you can change that to cosine squared if you wanted.
like this.
And then I think these are canceled in. And then what you've got on the left is sine squared.
And then
Wait, so cosine times
So you can use this again. Instead of saying sine squared, you can plug in 1 minus cosine squared. And then
This is
Jonathan, sit down. Jonathan, second time I'm asking you to sit down. this stuff to one. Yeah, because if you try to rearrange this, you could either sine and cosine are either both positive on this side, or you can move them over here and they're both negative. You're never gonna have a cosine that's positive and a sine that's negative. It's not possible to get those signs. So this can change to one times anything, so really you're just left with this on the next side. And maybe one more clue, because you're gonna need this for other questions too. So go ahead and copy that down.
Okay.
Okay, so when I look at that step, you've got sine squareds and cosine squareds, but you only want cosine. So this can change to cosine squareds. So instead of saying sine squared, replace it with 1 minus cosine squared. Then you're only going to have cosines in the answer.
Wait, hold on. Well, I know it's okay. I did that too, but is this the sign, is this supposed to be plus?
How do you know this comes out to 1 over cosine?
So it's gonna be this times.
Oh, you're not, okay, you're not.
Hold on. And then now it's gonna be cosine, 2 cosine. Is it gonna be 2 cosine? Because you're adding.
So usually when you do this horizontal, so that you can see the change in multiply by the reciprocal. And I think it would also help this purpose is cosine over sine.
Because this equals the one, like this.
What's
Pencils,
this?
and then it's like left
And you
with.
write this as cosine over sine, sometimes the cosine. But let me give you a different purpose. I'm not saying this is wrong, you can still run with that if you want to. I just think that you did the back order.
So it's like
Oh,
this.
that's the hardest one. You really should do that one. But we're already on
And
here.
then this turns into red.
Right here,
Wait, what?
dividing by something is the same as multiplying by something. Dividing by something is the same as multiplying by something. How do you divide this? Dividing by this is the same as multiplying by it. Or reciprocal. Same as multiplying by the reciprocal.
So,
Here. Instead of saying cosine divided by c times the reciprocal, so really this is like cosine times what? So all of that's gonna go to cosine squared eventually. And over here, it's the same as multiplying by. You say cotangent? Okay, so then you get all that just as
then you just read it.
and you're still not finished, but that seems to be like the road start. And I think you see the other thing. Question? Are you done with the worksheet?
Yes.
notes?
Are you gonna take a consumption?
Did you have a finish? No, I mean, you can turn them into What about the test reviews? Did you do 1 through 4 and
Cause like,
19?
I understand there's like different science whereas one of you science
Okay, that's fine. Just making sure.
but it ends up being the same thing. It's on the calendar, right?
One sec. Bless you. Okay.
What kind of stuff?
Alright, so difference of 2 squares to start it. Both of these look like the first Pythagorean identity. So why don't you write the first Pythagorean identity down so we can. So if we're willing to rearrange this stuff, can we ever get a sine squared plus 1 or can we get a sine squared minus 1? Yes. Do you have your pass? No, I mean, I sent you from the pictures. Your receipt or whatever?
I didn't give any. Oh, I have these things.
That should probably be.
But I might have to go back and deliver the full one.
I don't need to keep it, I just. There you go. Thank you. I emailed you back.
Yeah.
You'll still want to watch the very start of the class
I will.
recording for that information.
Thank you.
Wait, was that, did I give you? What did I get you?
Well, I thought I did beat on that quiz, like I was
And I
100%
just-
sure about
this
it,
is
and
early,
then I
this
like
is the-
realized that I did polarity wrong. No, I did polarity wrong, so I got a 0 on the quiz.
You don't need to worry about any of the rest. Okay. That sounds good.
Oh. Introducing
Well, look,
negatives.
I'm looking over here and I see that I only want cosine stuff. So if you can change anything in the cosine squared, it's probably a good idea. Okay. This is this. This one would be negative cosine Z. I may have had to substitute the wrong thing here, but that's okay. These are factors, so these can cancel. And then you can distribute your negative. So you've got a -1 and a negative sine squared after those cancel. Okay, and you want it to be cosine squared. The same substitution we did a minute ago. Instead of saying sine squared, you could put 1 minus cosine squared in here. You've got negative
Sorry?
sine squared is equal to what? Okay, so make that substitution. Okay, you still have the -1.
Oh.
You still have the negative. Okay, now when you distribute that negative, you've got a -1 here, and a -1 here, and a negative times a negative. Yeah, but you gotta think about what you have versus what you want, so that you know how to use this to make the switches. So I think if I had given you better advice a few steps before, we might not have had to do it sometimes, but that still works. Looks like you need to add those fractions together here.
Well, I know.
This is one big fraction, it's being multiplied, and that's a fraction. Get a common denominator and add those fractions together.
So,
I have no idea, I can't see that far ahead.
so you're saying turning into a fraction?
Okay, so put it over 1, he's already a fraction. Anything over 1 is a fraction. I understand.
So be negatives.
It's the same as sine over 1, if you really need to see it as a fraction. These multiply and become cosine squared over sine. That's a fraction as well.
So negative sine squared equals. Cosine squared equals 1.
Also, count it off and we don't have to
And minus 1.
I'm a little more lenient at the beginning of the year. I would say a lot of times on quizzes, if I see it once, I may not count off for it, but if I see it multiple times, I might take out. Mathematically, it makes no sense. Sine doesn't mean anything, it's the sign of something. Okay, now you've got two fractions, get a common denominator. Okay, that's good. And the whole point of the common denominator is so that you can squish those together as one big fraction.
And this is already 1 over sine, so I don't know. I think that here.
There you go, you got it.
Appreciate it.
But as as you're gonna see, and there's several of these you've got to add or subtract fractions. So. Yeah, that one done? Who's from last class?
Since
You got that.
bad combo. So weird. Just genius in a way.
You could separate them, but I don't think that's how it
Where are you in the?
I see that you want cosine squares, so having some cosine squares is probably good. You're reducing cosine sometimes squares. Again, that's where these two are frustrating. What you did is not wrong, it just ended up in helpful. You got raises right. So, why don't you just carry this down to one side.
So cosine or minus cosine squared?
And then a common trick is look at the left side of what you have, compared to the right side of what you want. You've got cosine squared on the left, and you want some cosine squared, so that guy.
And then you just do the same thing.
So we need to make this equal. So what is sine squared the same thing? If I solve this for sine squared,
Wait. Are you trying to change the cosine or
sine
sine
squared
squared?
equals 1 minus cosine squared.
So it's going to be cosine squared
1 minus cosine, the whole thing.
1
This is what
minus
you're
1. Why is it plus cosine? But not minus.
Okay, so if sine squared is equal to 1 minus cosine squared, you can make that switch right here. You've got cosine squared minus here, instead of calling that sine squared, we're going to call it 1 minus cosine squared. I think carry down the rest of it. Still have this that we didn't do anything with. You've got cosine squared.
I'll just.
And it was minus all of this, so it's still minus all of this. In parentheses, minus all of it.
Wait, can you just explain that whole thing? Why that's
Now, when you distribute this negative,
Like, why is that plus?
you do it.
Why does it mean
Which is,
plus
send your
cosine?
friends to the erase the plus line.
Dude, I put cosine on that. You said it was plus. I remember it was
We're
minus.
leaving this stuff alone. Cosine squared and minus. Then in place of sine squared, so parentheses. Sine squared is the same as what?
This is
Sine
what
squared
am I
equals-
supposed to do?
It doesn't say sine squared one. It says sine squared plus cosine squared. Solve this for sine squared. Sine squared is 1 minus cosine squared.
So that cancels.
Finish that.
Instead of this, putting what it's.
Or not. What is it? Teacher or just? Why did they give some? Oh, it's with the stuff.
And
So
then
definitely want
minus
this.
one.
Now, when you distribute this negative.
But you were.
Yeah.
So one.
Distribute it here, you're gonna get cosine squared, combine with that cosine squared.
If this is the level of difficulty and it's always.
But you have to see
So I have.
how I'm gonna change this to this. Because I saw that this had sine squared and this didn't, so
So
that made me a hint.
you say it's not getting it.
And you have to use one of these, you have to not make this decision. Because it does need to
I
be
don't
one.
see anything. Nothing is clicking up here. Like,
Sine squared only equals 1 minus. 11. What about you do the first 4 on the test review? And then, thank you.
I guess one of the times
Okay, well that's not true, so that can't be it. Let's see what you do. Okay, you're off here at the first bit. That's not how that factors. That's the difference of 2 squares. So you should have a sine squared minus 1 and a sine squared plus 1. Yep.
I don't know what I did wrong there.
Okay, well, difference of 2 squares. That is, why did it become a plus 1?
Because
I see this stuff, looks like this does, that looks like a green down. And this stuff is 1, but this is being times by, that's not added to that.
Oh, yes, okay.
Is that enough?
Yes. 7. So about 20.
Well, you could change everything to times and cosines and nothing else. Okay, so that's how you can select. Do you have a? Oh, okay, so let's check.
This is Canada. I'm guessing if this is
Click on one. So be careful right here. Part of what I think is right here. Sine squared plus cosine squared is 1.
Wait,
Right here you go. So this should be 1, but that should be a minus.
Oh my goodness. Do you remember that normal?
But on this side, you got cosine squared.
Do you remember that normal when I dressed up as Finale? Loki, if I found that,
Just you rearrange this first one.
I would really remind myself.
You make that substitution.
Times there.
They know what you did.
Yeah, I have.
Yeah, go all the way to that. You're almost there.
Water, we died.
But you see, you got 2 terms here. Term we're using as the cosine squared.
She's thinking hard.
Okay, so
Hardly
put
working
that out like you
or
should
working
get.
hard. Then we have to do titration. It's getting hard. It's no joke. It's no joke. This is what I've done so I did this, but I'm guaranteed that that's probably not. Oh, no, it's not.
To get them the same.
Oh, wait, I'm on this.
I think you kind of have a little short here. But I think it's just that the floating partial fraction is probably not. Well, yeah, that's what I said.
1 over secant is.
Again, there's nothing wrong with putting it up, that usually works, it's just that if you did it in, you got this fraction. But I noticed about it, I just started that.
Wait, I feel like I'm onto something.
That numerator is the difference of 2 squares. So you can do a sine squared minus 1. Sine squared plus 1.
And the next step is cosine.
Yep.
So you can factor this.
This is normal. I don't know why we did it.
Because of this.
Now, one of these, you can make a substitution, but only one of them.
So you're going to factor in.
So when you kind of look at this really carefully,
Two cosines, right?
you could get a sine squared minus 1 if you subtract it over. A sine squared minus 1 would be equal to what?
Sine squared minus 1.
Almost.
Because of this.
You're gonna have to subtract it over 2, so it's gonna be negative. See what I'm saying?
And then you'll keep
That's true. Sine squared, subtract this over. Sine squared by minus 1. We have to subtract this over 2, which makes it negative. Place of that, you can put negative cosine.
That's
Sine minus 1 is cosine.
Yeah, that's how I look at that. So if you have cosine of this denominator sine.
Bro, I hope.
You see why the cosine has to be negative there?
Because that comes out to be cosine.
Well, then these cancel, these are factors, so you can reduce those. You can distribute this.
Yeah, no, so that's,
Minus 1. But I think the problem is, you want cosine squared, it's not sine squared. So we can use this guy again. So if I solve him for this,
I'm confused with that statement.
sine squared is equal
Because
What would that
secant
be?
is so
you're subtracting this over, so it's going to be
so this
minus.
goes back to the,
I think they're figuring to do this.
yeah, it's,
So in place of sine squared,
sine squared.
1 minus cosine. But those signs are important.
If you,
Now when you distribute this, you've got a minus 1 and a
but
minus 1.
anyways, that's what it comes out to.
Minus 2.
That's
You've
what
got a
we should
negative,
we could do.
times a negative, and take you to a
I
positive.
think you know, it's just like-
And then that's the process. I'll take a look. Okay.
Understand what you did at the end, so I got to, so I know that I can only use this one because assuming I'm not getting cosine.
But then I forget, what is tangent? Tangent equals sine of the cosine of the
But after that.
Well, there's no way to rearrange this and ever get that. Sine, if you subtract this over, sine becomes negative, if you subtract this over, 1 becomes negative. So yeah, that one's got to stay the same. Okay? So what is sine squared minus 1 equal to?
Okay, my only point is that it's
Squared.
It's not cosine squared though. That's where
Yeah.
your mistake is. It's negative cosine squared. If you got to solve this carefully. It was what, 1 sine squared minus 1. So leave this alone. Subtract the 1 over.
Sign.
Sine squared minus 1. So you're going to have to subtract that over, which is what's the negative cosine squared.
I'm just gonna leave it.
Just a second. I saw his hand first. That's fine.
Okay.
Yeah, there's some.
All
I
right.
can get you some pages for this work. Did you do 19? 19 of the other ones?
Since we
Okay,
won't have
common
time to
denominator.
do chemistry, or what would I say, like chemistry assignment for school.
I don't know. I'm with you on the common denominator. I don't know.
Okay, well, I think,
Your numerator looks okay too.
maybe,
but I don't know
No, I don't.
what happened with this.
Okay.
To me, it looks like you have cosine times 1 minus sine.
Yes.
Okay, but what happened with that? Because if you distribute that, you should have a cosine minus sine cosine. And I don't see that in any of your work.
Oh, I think that too. Cosine.
But that doesn't work. This only works if they're squared. 1 minus sine squared is cosine squared, but 1 minus
Okay,
sine is not
okay.
cosine.
Okay.
Similar, but just like Pythagorean theorem, a squared plus b squared equals c squared always works in right triangles, but a plus b doesn't equal c. The squares have to be there, or it doesn't work anymore.
Is this like illegal if I just like move the negative over there?
Well, I'm gonna just make up numbers for these. Is 5 minus 3 the same thing as negative 3 times 5?
No. Please, just let me keep it.
You gotta keep going.
This
Change
is
this.
tragic.
I told you to do this one last because it's the hardest.
Yeah.
Change this into cosine squared over sine squared.
Cosine. Oh.
Okay.
Okay, Catherine.
And then you can add those fractions together, and that's how you get them together as one big factor.
Oh. Like, okay.
Common denominator, push them together.
Yeah. No, that should be different.
Right here, cosine plus cosine is not cosine squared. That would be cosine times cosine, which would be cosine squared. Right here, you should have 2 cosines, 2 regular cosines.
I think you can do it in 5 minutes. Oh my god.
No, I was gonna
Oh, yeah,
staple
you're
them,
right.
sorry. I only suggested doing 1 through 4 and 19, because those will be on the quiz too, so if you do those early, you're not cosine squared.
No. Are these both 18 or are they 17?
Seven, you don't have them, you have 17.
Oh, yeah.
So your numerator becomes 2 cosine. So go ahead and add those together, 2 cosine. Okay, and then how can you make that denominator? So this thing is 1 minus sine squared. What is that? You rearrange that, so 1 minus sine squared. What do you want to do? No, but that's how you should move forward. I mean, you don't have to. And then cosine divided by cosine squared, how did that reduce? What's x divided by x squared? This is like cosine squared is like cosine times cosine. So if you write that out as cosine times cosine, you can see that one of the cosines cancel. Carry down the numerator. See the cosine cancel, and you're left with 2 cosine. It's just one. Leave it right there. But you gotta know how to make this look different, and so the key is using that and subtracting it over, so that you can make it look different. Does that make sense? Okay, so where are you?
So some of this I was, I just didn't understand what you're talking about.
You can have a lot of homework.
So, so this
What is this? sine squared minus 1 is not equal to cosine squared minus 1 or negative.
Yeah, I'm gonna start. I'm gonna walk through this.
So that gives me sine squared theta plus 1 minus 1, which completely gets rid of the points around the sine squared.
Why is it get rid of the 1?
Oh, never mind, because it would multiply it when you subtract.
Right here, I see you've got all of this times cosine squared divided by and then you need one more substitution. You're going to have sine squared stuff on the left, but it's in sine squared. You can say 1 minus this. And you make that
But like, you can, I swear. That's right. Yeah, you're gonna finish it.
All right, you guys are down to about 6 minutes, so maybe finish up the question you're on. Make sure that you turn those things in the Google Classroom before I see you on Thursday. Again, 24 of the 30 points are like the book problems, so it is in your interest to scan the book assignment, look at the questions you missed initially, look at the notes you made yourself, hopefully, and we'll have that quiz at the start of the next class. You're welcome to work more of the test review than I assigned, but please do at least 1 through 4 and number 18. Again, that will help you be a little more prepared for our 4-3 quiz. Of course, it wouldn't hurt you, wouldn't be a bad idea to review the trig proofs as well, but typically the trig proofs are not what people struggle with on that goes, so.
They asked me to come back like right before 1, okay?
Do what?
They asked me to come back like right before 1.
Oh, you didn't get it done yet?
So I
Okay,
got
go
like
ahead.
the first one.